Assalamu alaikum. I hope you all are fine. Today we are going to end exercise 3.1 as previously we have done question number 1 of 3.1. Today we are starting with question number 2 in which x, y and z three sets are given with their elements and we have to solve the given operations using Venn diagram. So first operation is given x union y union z. We have to represent this by using Venn diagram. So in first part, since you can see the set x, y and z, here y is a subset of x, so we make it like this: x in y, y in x, and z is not a subset of any of these sets, so we make it like this. So first operation for this, we have to first shade the area of x union y. X union y mean all elements of x and y. So we have to shade all elements of x and y, that is we shade it by horizontal lines. And write it as x union y equals to all horizontal shading. X union y union z mean all elements of x, y and z, so we also shade the diagram z with the horizontal lines. So the total shading we show of x union y union z equals to horizontal line shading. In second part, we have to shade x union y union z. So we make the Venn diagram and write the element in such a way, since y is a subset of x, so we write the common element of x and y in y, that is a, c, e, and remaining element of x are b and e, and we write it like this. And all element of z are I, g, h, I, j. So first we have to shade x union z. It means all part of, sorry, y union z, all part of y and z. So we shaded it with the horizontal line, all part of y and z. And represent this shading as horizontal lines. X union y union z, it also means that all elements of x, y and z, so we have to shade all the Venn diagram, all element of x, y, z, and we shaded x also with the horizontal lines. So the required shading is all horizontal shading. In third part, we have to shade x intersection y. X intersection y mean common part of x and y, so common part of x and y is y set. We shaded it with the horizontal line. X intersection y is represented by horizontal lines, and x intersection y intersection z, it means common part of the shaded area and z. Since they are not overlapping set, there is no common part between z and y set, so there is no shading. In fourth part, we have to find the operation x intersection y intersection z. So y intersection z mean common part of y and z. Since there is no overlapping between y and z, so there is no common part of y and z, and we write it as y intersection z is equal to phi set, no shading. And the intersection of x with y intersection z is also phi set, there is no common part, so no shading in this part. In fifth part, we have to find x union y intersection z. So first we have to find x union y. shading. X union Y mean all shading of X and Y. So we shaded it with the horizontal line. Now X union Y intersection Z. It means the common part of this shading and Z. There is no common part of the shading and part Z. So no common area. The answer is phi and no shading. In last part we have to find X intersection Y union Z. So first we have to find X intersection Y. Since there is a common part of X and Y is Y, so we shaded it with the horizontal lines and write it like this: X intersection Y union Z. It means the common part of X and Y and union of Z, all part of Z. So we shaded Z with also horizontal lines and represent this shading as all horizontal part. So the shading of X intersection Y union Z is the shading of Y and Z. Is the question number 3 of exercise 3.1 is verify associative law of union and intersection by using diagram of question number 1. So you have to apply associative of law of union and intersection on all the 4 diagrams of question number 1. So I do it by using first Venn diagram and apply associative law of union and intersection. The remaining second, third and fourth you have done it by yourself, and if you have any problem you can comment me. So by considering first Venn diagram of question number 1, that is this, so we have to apply associative law of union first, which is A union B union C equal to A union B union C. So in left hand side we first pair A union B with C, and then in right hand side first we have to shade the area B union C and then with A. So we have to draw the two Venn diagrams for each part. So for left hand side that is A union B and union C. So first we have to shade the area A union B. A union B. A union B means all the area of A and B is shaded. We shaded it with the horizontal lines A and B. We shaded A and B with horizontal line, that's all area of A and B, and we write it as this. Now A union B union C, it mean all area of A, B and C, so we shaded C also with horizontal lines like this. So it means that A union B union C shading is all the horizontal area of the Venn diagram. So we done the left hand side shading. Now we done the right hand side shading of associative law of union, that is A union B union C. So first we shaded B union C. B union C mean all the area of B and C, shaded with horizontal lines. We shaded it like this. So we shaded it with horizontal lines, and now A union B union C, it mean all area of A, B and C, so we also shaded A with horizontal lines. So shading of A union B union C is also the horizontal shading of Venn diagram. So as you can see, the left and right hand side of associative law of union shading is same on both the sides, so both sides are equal to each other. Now we have to prove the associative law of intersection on same Venn diagram of question number 1. First part, that is A intersection B intersection C is equal to A intersection B intersection C. So first we shade the left hand side, that is A intersection B. So first we find A intersection B shading. A intersection B shading mean common part of A and B. Since A and B are not overlapping and there is no common part of A and B, so there is no shading, only phi set. And A intersection B shading, and A intersection B intersection C is also equals to phi set, so there is no shading. So there is no shading. Now proving right hand side, that is A intersection B intersection C. So first we shaded B intersection C part, common part of B and C. Common part of B and C is this. We shaded it with horizontal lines, and now the intersection of A with common part of B and C. Since there is no common part of this shading with A, so it's also equals to phi set, no shading. As you can see in left and right hand side, the two answer of A intersection B, left hand side there is no shading, and for right hand side also there is no shading because there is no common part. So left hand side and right hand side equal to each other using Venn diagram shading. So I prove associative law of union and intersection on first diagram of question number 1. I hope you will understand. The remaining part you have to done by yourself. Question number 4 of 3.1 is that verify distributive property of union over intersection and distributive property of intersection over union by using diagram of question number 1. So I use the second Venn diagram to prove these properties of first union over intersection and then intersection over union. So distributive property of union over intersection is that A union B intersection C, that equals to A union B intersection A union C. So we shade both left and right hand side on the second Venn diagram of question number 1, that is left hand side and right hand side shading. So first we shade this left hand side, that is A in union B intersection C. So first we shaded B intersection C part. It means common part of B and C. The common part of B and C is this part. We shaded it with horizontal lines. Now A union B intersection C. A union B intersection C mean all part of B intersection C, common part and E. So we shaded E also with the horizontal line and represent this overall shading as all horizontal part shading. So A union B intersection C is equals to this A shading and this part. Now we shaded right hand side, in which first we shaded A union B. So A union B equals to all part of A and B. So we shaded it with horizontal lines. In this part A union B mean all part of A and B. We shaded it with vertical line A and B like this, A and B, shading like this. Shading of A union B, we shaded it with vertical lines. Now the shading of A union C. A union C mean all part of A and C, so we shaded it with vertical lines. Now the common part of A union B intersection A union C. Common part of the vertical and the horizontal sides. As you see, the common part of the vertical line and the horizontal line is this part, and this part A. So this shading is by mistake. So the common part of A union B intersection A union C is the purple shade highlighting. So purple highlighter part is the shading of A union B intersection A union C, and you can see that in left hand side we also shaded the same part. So the distributive property of union over intersection is proved by Venn diagram. We write it as now in the second part we have to prove the distributive property of intersection over union, that is A intersection B union C equals to A intersection B union A intersection C. So first we shaded the left hand side of this property, that is A intersection B union C. So first we shaded B union C. B union C mean all part of B and C. So we shaded it with horizontal line, all part of B and C. A intersection with B union C. The common part between A and that horizontal shading, so the common part is only A. So we shaded A with horizontal lines, and the common part between A and that horizontal shading is A itself. So this shading is represented by double line of vertical and horizontal lines. Now proving right hand side, first we have to shade A intersection B. A intersection B mean common part of A and B. As there is no common part of A and B, they are not overlapping set. So the intersection of A and B is phi. Now A intersection C. A common part of A and C, since A is a subset of C, so common part of A and C is A part, A set. We represented it with horizontal lines. So A intersection C is equals to shading of horizontal lines. Now A intersection B union A intersection C as a union of phi set, and this horizontal shading is also equals to horizontal shading. So you can see in left hand side the shading of A intersection B union C is double line shading of horizontal and vertical, which is A set, So the answer of left hand side shading is A set, and in right hand side intersection union of A intersection B and A intersection C is also equals to A set. So both left and right hand side shading is A set, so they are equal to each other. Question number 5 of 3.1 is proved by using Venn diagram. So there are two parts given. Part 1 sets PQR are these, and part 2 sets PQR are these. So first we have to apply these two operations A and B on one part, and then apply these two parts A and B on second part. So we started it by applying both A and B operation on first part. So we start question number 1 by considering first part elements of PQR, and we have to prove this associative property of union on these parts, and then prove intersection property of associative law of intersection on these parts. As PQR are given, so you can see that P and Q are overlapping set. The common part of P and Q is 2 and 3, and QR are overlapping set. Common part is 5 and 6. So I made the diagram as this. So first, associative law of union, we shaded the left hand side. That equals to P union Q union R. So the shaded part of P union Q. P union Q mean all part of P and Q. P union Q mean all part of P and Q. So we have to shade it all part of P and Q. That equals to horizontal shading of P and Q. And represented it with the horizontal lines. Now P union Q union R, it means shaded all parts of P, Q and R. So we also shaded R with the horizontal lines. So this is the final shading of left hand side, in which all P, Q, R are shaded with horizontal lines. Now we shaded the right hand side, which equals to P union Q union R. So first we shaded Q union R. It means all part of Q and R, we shaded it with horizontal lines. And represent it with this. Now P union Q union R, it means all part of P, Q and R are shaded. So we also shaded P with the horizontal lines. And the final shading is all part with the horizontal line shading is the right hand side shading. So you can see from both Venn diagram that left and right hand side shading is same. So we proved the associative law of union in this part. Now proving associative law of intersection on PQR. So first considering the left hand side, that equals to P intersection Q intersection R. So here the shading of P intersection Q, it means the common part of P and Q. So common part of P and Q is this part. We shaded it with the horizontal lines. Now P intersection Q intersection R. Common part of this shading and R. Since there is no common part of this shading and R, so there is no shading. Now proving right hand side, that equals to P intersection Q intersection R. So first we shaded Q intersection R, common part of Q and R. So common part of Q and R is this shading. Now P intersection Q intersection R, a common part of P and this shading. There is no common part of P and this shading. So right hand side also no shading. So from both Venn diagrams you can see that associative law of intersection is satisfied from Venn diagram. Left and right hand side are equal. There is no shading on both Venn diagram. The final shading of left and right hand side is no shading. Now we solve the question number 5 by using these sets P, Q, R, second part, and apply the same associative law of union and intersection on these set and prove it by Venn diagram. As you can see from sets that P, Q, R, here the overlapping sets are Q and R. Common part between Q and R is T and U. So first we shaded the left hand side. So in left hand side first we shaded P union Q part. P union Q mean common part. Sorry, all part of P and Q. All part of P and Q are shaded. We shaded it with horizontal lines. And write it as this. P union Q union R mean all parts of P and Q are shaded, so we also shaded R with the horizontal lines. So the final shading of left hand side is all the horizontal parts. Now shaded the right hand side, that equals to P union Q union R. So first we shaded Q union R part. All part of Q and R are shaded with the horizontal lines. Now P union Q union R mean all part of PQR are shaded, so we also shaded P with the horizontal lines like this, and the right hand side total shading is the horizontal shading. So from both left and right hand side Venn diagram you can see the shading is same. The total area of PQR are shaded on both left and right hand side. So we prove the associative law of union on second part of question number 5. Now we prove the associative law of intersection on these PQR sets. So first we shaded the left hand side, that equals to P intersection Q intersection R. So first we shaded the P intersection Q part, a common part of P and Q. Since P and Q are not overlapping sets, so common part is not phi set, it's a phi set, there is no shading. And P intersection Q intersection R, intersection of phi and R set is also phi set, so there is no shading. So in right hand side, which is equals to P intersection Q intersection R, so first we shaded the part Q intersection R, which means the common part of Q and R. Q and R common part is this. Now intersection of P with common part of Q and R. Since there is no common part between P and Q intersection R, so it's also equals to phi set and there is no shading. So in both left and right hand side there is no shading, so these are equals to each other and we prove the associative law of intersection. In question number 6, we have to verify the distributive property of union over intersection using a Venn diagram for the following sets x, y and z. Here x and y are a subset of z, so we make the Venn diagram like this. So first we shade the left hand side shading, that is x union y intersection z. Y intersection z is a common part of y and z. Since y is a subset of z, so only shade y part, y diagram. We shade the y diagram with the horizontal line and we shade x with the vertical lines. So the union of x and y intersection z is all part of x and y. So we write it as all vertical and the horizontal shading. In right hand side, first we have to shade the part x union y, all part of x and y. We shade it with the horizontal lines. Now x union z is represented by vertical lines. So common part between x union y and x union z is x and y, which have a double shading of both line vertical and horizontal lines. So we represent the final shading of x and y at double lines vertical and horizontal that make box. So the shading of both left and right hand side gives the shading of x and y and is equal to each other. Question number 7 is verify the distributive property of intersection over union using the sets x, y and z. So first we write the set in set form. Write the element of these sets. X, a set of first three vowels, so we write x as, here we write x equal to, first three vowels are a, e, I. A, E and I. We write elements of y as a word energy, and the elements of set z are all the letters of algebra. So first we solve the left hand side, that is x intersection y union z. First we find y union z, it means all the elements of y and z are written. So we write all the elements of y and z. The elements that are common, we write them one time. So write the first element, that is e. A N R G Y B and L. So Y union Z is equals to E A N R G Y B L. 8 elements are included in Y union Z. Now the intersection of X with Y union Z, common part. First we write the elements of X, A, E, I, and the intersection of Y union Z. Write the element of Y union Z that we find above. Now common elements between these two are only A and E. So we write the element A and E. So X intersection Y union Z equals to AE. Now we find the right hand side, in which first we find X intersection Y. So we write the element of X as AEI and intersection with Y set. So the common elements of X and Y are only E. Now we find the intersection of X and Z. X intersection Z, write the element of X as AEI, intersection element of Z ALGEBRA. So the common part between X and Z is A and E. Now we find the final answer, that is a union of X intersection Y and X intersection Z. The elements of X intersection we find is E, and the element of X intersection Z are AE. So their union is equals to AE. Hence right hand side is equals to left hand side. As you can see, this is the equation number 2. And in equation number 1, the answer is AE. Both sets have same elements A and V. So we prove this distributive property. Here we have completed exercise. I hope you will understand. Please like and subscribe my channel and share with your friends.